Inert pair effect. It is defined as reluctance in the participation of outermost s subshell electron pair in chemical bonding due to increased effective nuclear charge. This effect is applicable in group number 13, 14, 15 and 16 of P block, and it is mainly applicable for the bottommost element of these group. Take example of group 13. In group 13, there are elements boron, aluminium, gallium, indium and thallium. So inert pair effect is applicable in group 13. Okay, now what is inert pair effect and what is its cause, we'll discuss by taking the electronic configuration of thallium. The atomic number is 81. The valence configuration is 6s2 6p1, and before this valence we fill xenon configuration, and between 6s and 6p we fill 4f14 and 5d10. Clear? So these electrons 4f and 5d electrons, especially talk about the 4f electrons in which we have filled 14 electrons, they cause very poor shielding effect. You know that the order of shielding effect is S, P, D and F. The S subshell electrons cause strongest shielding effect, and as you move from S to F, the shielding effect decreases. So 4f electrons cause very poor shielding effect. These cause very poor shielding effect. Okay, but simultaneously you are placing protons in the nucleus, and these protons will increase the nuclear charge. Shielding by the 4f electron is weaker, so the effective nuclear charge will be largely increased when you place protons in the nucleus, and this largely increased nuclear charge will hold the valence electrons very strongly, and so they will not be allowed easily for participation in chemical bonding. Especially the s subshell electrons will not be allowed to take part in chemical bonding. 6p may be allowed to some extent, but 6s electrons participation become very difficult. You can understand on the basis of this diagram. This is nucleus, this is s subshell orbital of a shell, and in the same shell this is one of the p orbital. Okay, now penetration ability of s electron is high as the distance between nucleus and this electron is less, but the penetration ability of an electron of p subshell is less because the distance of this electron from the nucleus is high. So nucleus hold s electron firmly, but its hold on the p electron is weaker. Therefore, when in thallium effective nuclear charge increases, its hold on the s electron will be stronger, and on the p electron it will be weaker. So s subshell electron will not be allowed in chemical bonding. Only the p electron can take part in bonding, and therefore the thallium, by losing its 6p electron, can produce Tl+, but loss of 6s electrons is difficult, and that's what why Tl plus 3 formation is not easy. If it forms, then it will be unstable and it tends to convert back again to Tl plus. Okay, so this is the inert pair effect. Once again, I want to explain what is inert pair effect. The reluctance in the participation of S subshell electron pair in the chemical bonding due to increased effective nuclear charge. And that is due to very poor shielding effect of 4f electrons. Okay, so what is the cause of inert pair effect? The very poor shielding effect of 4f electrons. They cause increase in the effective nuclear charge very largely, and that's why the S subshell electron don't take part in chemical bonding easily. So this is the cause of inert pair effect. And now what is the consequence of this inert pair effect? That thallium for only plus 1 ion, plus 3 ion of this is less stable. Okay, the other element of group 13 means boron to indium. For them plus 3 state is stable, plus 1 is not so stable. Why? Because after losing 3 electrons they get the noble gas configuration, and that's why boron to indium all make plus 3 state. But in thallium plus 3 state is less stable and plus 1 state is more stable. So in this way the stability of plus 3 state down the group decreases, and for plus 1 state the stability increases. This is the consequence of inert pair effect. In thallium the plus 1 state is more stable than the plus 3 state, whereas in indium plus 1 state is less stable than the plus 3 state. So this is all about the inert pair effect in group 13. The same thing you will observe in the group 14, where plus 2 and plus 4 two states are possible. For the bottommost element lead, Pb plus 4 state is less stable than the Pb plus 2 state, whereas the element above to it, that is Sn, here the plus 4 state is more stable than plus 2 state. Why? Because in Sn inert pair effect is not applicable, but in Pb it is applicable. Okay, the same thing you will discuss in class 12th, in 15th group and in 16th group. Thank you.